Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. X undergoes 1. NaOH, 2. Heat, 3. H2PD, 4. Lyl4 then H2O to give the final product. Moving on to the next step. Work backwards from the product. The final step is Lyl4 followed by H2O, which reduces a carbonyl group, aldehyde or ketone or ester, to an alcohol. Since the product is a primary alcohol, terminal CH2O, the precursor before Lyl4 must be an aldehyde, terminal CHO. Moving on to the next step. The step before Lyl4 reduction is H2PD, catalytic hydrogenation, which reduces AC is equal to C double bond to AC to C single bond. So before hydrogenation, there was an alpha, beta unsaturated aldehyde, enal, with AC is equal to C adjacent to the CHO. And for the final step, the step before hydrogenation is heat, elimination, condensation. The step before that is NaOH. The combination of NaOH then heat suggests an aldol condensation followed by dehydration, giving an alpha, beta unsaturated carbonyl compound, aldol dehydration product is equal to enal. After aldol condensation and dehydration we get an alpha, beta unsaturated aldehyde. After H2PD we get a saturated aldehyde. After Lyl4 H2O we get the primary alcohol, the product shown. If we convert CH2O back to CHO, we get a saturated aldehyde. The product structure, analyzing the image, corresponds to 4-methylhexane 1 or when the CH2O is considered, meaning the saturated aldehyde precursor is 4-methylhexanol. The alpha, beta unsaturated aldehyde, enal, before H2PD would be 4-methylhex-2-enal, with the double bond between C2 and C3 conjugated with the aldehyde at C1. This enal is formed by aldol condensation and dehydration, NaOH, then heat, of compound X. An alpha, beta unsaturated aldehyde formed from aldol dehydration of a single aldehyde with itself, self-aldol, or crossed aldol. For 4-methylhexanol to form via reduction of the enal and the enal to form from NaOH plus heat of X, compound X must be the simple aldehyde, 4-methylhexanol, option D, which undergoes self-aldol condensation, NaOH, to give beta-hydroxyaldehyde, then dehydration, heat, to give the alpha, beta unsaturated aldehyde, 2,2-methylbutyl, but 2-enal or similar enal. Then hydrogenation and reduction gives the observed product. O is equal to CH, CH to CH to CH, CH3, CH to CH3 is 4-methylhexanol. NaOH causes aldol condensation, self-condensation, heat causes dehydration to enal, H2PD reduces the C is equal to C giving saturated aldehyde, Lyl4 H2O reduces CHO to CH2O giving the branched primary alcohol shown. A and B are already alcohols. They would not undergo NaOH heat H2PD sequence to give the product. C is a longer chain aldehyde, 5-methylheptanol, that would give a different product with extra carbons not matching the shown product. Only D, 4-methylhexanol fits the retrosynthetic analysis. Therefore, the correct answer is D. Therefore, the correct answer is option D.